Hello guys, so we are going to continue the discussion with respect to statistics, and in this video we are going to discuss about a very important topic which is called as covariance and correlation. In this video, the agenda will be that we'll try to understand about covariance, what exactly covariance is used for. We will be seeing multiple examples. Then we will be seeing what exactly is correlation, what is the differences between covariance and correlation, and some of the amazing use cases, how we can use it as a data scientist or a data analyst. So all those things will be specifically covered in this video. So first of all, we will go ahead with the definition. So over here, the definition is pretty much simple. So covariance and correlation are two statistical measures used to determine the relationship between two variables. This is really very important. If you really want to find out the relationship between two variables, and specifically these variables are continuous variables, both are used to understand how changes in one variable are associated with the changes in another variable. Okay. So for both this, if we really want to quantify this relationship between two variables, we can actually use covariance and correlation. Now, first we will go ahead with covariance. We'll understand the formula. We'll solve some problems over here, and then we will further go ahead and understand about correlation. So again, covariance definition is given over here. Covariance is a measure of how much two random variables change together. If the variable tend to increase and decrease together, the covariance is positive. If one tends to increase when the other decreases, the covariance is negative. Okay. So here, when it is positive and when it is negative. Okay. So initially, as usual, let's consider an example. Let's say I have two random variable x and y. Okay. Now in this x and y, this can be a features in a data set also. Let's say I have some values. I have like 2, 4, 6, 8. Okay. And let's say in my y, I have 3, 5, 7, 9. Okay. So here specifically I have two random variables x and y. Okay. And with respect to this x and y, every record I have some data over here, right? I have 2, 3, I have 4, 5, I have 6, 7, I have 8, 9. Okay. Now, if I really want to find out a way to quantify the relationship between x and y. Now, when I say quantify, what does this basically mean? I will take this x and y variable or random variable, and I'll try to find out some relationship between them, right? Now, what kind of relationship can be found out from this? Let's say in this particular data, I want to look for a relationship like if x is increasing, whether y is increasing, or if x is decreasing, whether y is increasing, or if x is increasing, whether y is decreasing, or if x is decreasing, whether y is decreasing. So this kind of relationship I really want to find from this particular data. Okay. And in order to find out this relationship in some numerical format, we can specifically use covariance and correlation. But here, since we are starting with covariance, now let me take a very good practical example. Let's say I have a feature which is called as the size of the house. Okay. And the other feature that I have, price of the house. So let's say this is my data set. Now in this data set, let's say if the size of the house is somewhere around 1200 square feet, let's say the price is 45 lakhs. Okay. If I increase this to 1300 square feet, let's say over here, I will go ahead and write 50 lakhs, right? If I keep on increasing again, 1500 square feet, let's say over here, I have 75 lakhs. So do you see some kind of relationship? As the area of the house, as the size of the house is increasing, the price of the house is also increasing. So this is the relationship with respect to this particular data. Not only that, if the size of the house decreases, then this price will also decrease. So both this scenario is basically getting satisfied from this data set that we have. But at the end of the day, we need to find out a way to find out the relationship between x and y. And we should be able to give some numerical number to it, right? That is what I'm talking about. That is nothing but quantifying the relationship. Now, let's take this all relationship and build some diagrams over here. Okay, so I'll create some scattered plot. Let's say this is my x comma y. Okay. Let's say over here, I have my x, I have my y. Now let's focus on this x comma y. What kind of relationship this data is basically following. See, when x is 2, y is 3. When x is 4, y is 5. When x is 6, y is 7. When x is 8, y is 9, right? So if I just see this data set, right, and if I just keep on plotting, don't you think we are following this specific pattern, right? So as x increases, so here two important pattern we are seeing. When x increases, y is also increasing, and when x decreases, y is also decreasing, right? So this two patterns we are able to see from this specific data set. Okay, this is really much important to understand. Okay, the other pattern, one more pattern that we can specifically have. Okay, let's draw the other pattern, which is possible with respect to this x and y random variable. Let's say I have x and y. Now this time, let's take one example. Let's say I have my x and y over here. I'll say, hey, this is 7, y is 6. Let's say this is 5, this is 4. This is 3, this is 2. This is 1, this is 0. Now in this scenario, when x is decreasing, see, okay, this is, let me just change this particular example a little bit. Okay, so here, one scenario was that when x is increasing, y is increasing, right? So when x is increasing, y is increasing. When x is decreasing, y is decreasing, right? One example can be, let's say if I go ahead and write like this, 7 is equal to 10, 6 is equal to 12, 5 is equal to 14, 4 is equal to 16. Now in this scenario, don't you see the relationship looks something like this? When x is decreasing, y is increasing. Yeah. When x is decreasing, y is increasing, right? 10, 12, 14, 16. When y is decreasing, do you see x is increasing, right? If from 16 to 14 it goes, at that point of time your x increases. So this relationship is basically satisfied by this, right? If I probably consider this data set, it satisfies this relationship. Now similarly, if I try to plot it, my data points will look something like this, right? Let's say I'm just plotting it like this. And this satisfies this particular relationship, right? Now usually if we go ahead and use covariance, okay, and covariance actually helps you to quantify the relationship between x and y, okay, that is two random variables. Usually when we apply covariance for this kind of relationship where x is increasing, y is increasing, x is decreasing, y is decreasing, here you get something called as a positive covariance. Positive covariance basically means if you calculate the covariance, I'm going to get some positive value. Why? Because x is decreasing, x is increasing, y is increasing, x is decreasing, y is increasing. For this kind of relationship, if I go ahead and try to calculate the covariance, I get a negative covariance because it is opposite. When x is decreasing, y is increasing. So this here you are going to get a negative value. Okay. Now you may be thinking, Krish, how you're saying positive covariance or negative covariance? Let's do it with the help of calculation. Okay. So usually if I go ahead with the covariance formula, the covariance formula looks something like this. Okay. So if I just go ahead and write covariance x comma y is nothing but summation of I is equal to 1 to n. I'm just taking a sample size n. Okay. Sample size n. I cannot consider population because it is difficult. We do not have the entire population data. Let's consider that. Then here I will go ahead and write x of I minus x bar. Okay. Then you have y of I minus y bar divided by n minus 1. Okay. So this is the entire formula for covariance. Now you may be thinking this formula looks little bit different, little bit similar. Okay. To what? Okay. And this can be a really important interview question. Do you remember if instead of finding x comma covariance of x comma y, if I go ahead and write covariance of x comma x, now in this scenario, what will happen? X of I minus x bar, this will become, so let's go ahead and write summation of I is equal to 1 to n, x of I minus x bar, and this y side is also x. So if I'm trying to find out x, relationship of x with x, right? Relationship of random variable x with x, it is nothing but if I go ahead and take this, it will be the same thing, and this will be divided by n minus 1. And this is nothing but this is equal to variance of x. So covariance of x comma x is nothing but it is equal to variance of x. Please try to understand this, okay? And this is what we have actually proved. If you remember, what is this formula? This is nothing but variance of x only, right? How do we write variance of x? Nothing but summation of I is equal to 1 to n x of I minus x bar divided by n minus 1 whole square, right? This was my variance formula. So covariance of x to x, that basically means if I want to find out the relationship with respect to x, it is nothing but variance of x. So this in short is talking about the spread of the data, right? But if we need to find out the relationship between one random variable to the other, then this is the formula that we specifically use. Okay. So let me just go ahead and write more about this. So here I'm going to go ahead and write x of I. X of I is nothing but my data points of random variable x. Okay. Then what is x bar? X bar is nothing but sample mean of x. I hope this is really simpler and simple for you all to understand. Y of I, what it is? Data points of y. Data points of a random variable y. Okay. Now if I go to the next data point, it is nothing but y hat. Y hat is nothing but sample mean of y. Now let's see whatever I have said till now. Okay, whatever I have actually said till now, this if this follows this particular thing, do we get a positive covariance? If this follows this particular relationship, if x and y follows this relationship, do we get a positive covariance? If x and y follows this relation, do we get a negative covariance by using this formula? That is what we are going to see. So let's solve one basic example and let's see how things work out. Okay. So here, let's consider one example of, I have some data of some students. Okay. Now this data has something like this. Let's say over here, I'll go ahead and write hour studied. This is nothing but number of hours studied. Let's say this is my x, and this is nothing but exam scores, which is my y. Okay. So in this scenario, let's say if the person is studying for 2 hours, the person has got 50 marks. This person has studied for 2 hours daily. Let's say if this person has studied for 3 hours daily, this person has got 60 marks. Then 4, then I have got 70 marks. 5, I've got 80 marks. And 6, I've got 90 marks, right? Now, just by seeing the specific data, you know that what kind of relationship this is following. This is nothing but when x is increasing, y is increasing. When x is decreasing, y is decreasing, right? This is the relationship that it is following. And we have already seen this will definitely follow some kind of positive covariance. The final output that we are going to get is getting a positive covariance. Why? Because x is increasing, y is increasing. When x is decreasing, y is decreasing. So x is directly proportional to y, right? So let's go ahead and calculate this entire formula, right? So I will take this entire formula and we'll go ahead and calculate it. Let's calculate and let's see whether we'll get a positive covariance or not. And I hope so we get it, right? If my calculation is absolutely perfectly fine. So first thing first, what we need to calculate? The first thing that we need to calculate is x bar, right? Over here we need to calculate x bar, y bar. What is x bar? X bar is nothing but 2 plus 3 plus 4 plus 5 plus 6 divided by 5. It is nothing but, if you see this, it will be 4. Okay. Second thing that we need to calculate is nothing but y bar. See, 5, 9, 14, 20 divided by 5 is 5. Okay. Y bar, in order to calculate y bar, I have to go ahead and write 50 plus 60 plus 70 plus 80 plus 90 divided by 5. It is nothing but this will be equal to 70. I've done the calculation. You can just check it out. So I've got my x bar and y bar. Okay. Now let's go ahead and calculate the covariance of x and y. Okay. So now I will just go ahead and write covariance of x comma y is nothing but, first of all, x of I minus x bar. What is x of I minus x bar? And it is summation. Please remember this. It is summation. Okay. Summation of this from I is equal to 1 to n. So this is my I is equal to 1, 2, 3, 4, 5. Like there are total 5 records. Okay. So first I have 2 in x of I and y of I have 50. So I'll go ahead and write over here 2 minus, what is my x bar? 4. Y bar I know it is 70 and the first value that I have is 50, right? So 50 minus 70. Now I'll go to summation. I have to go to I is equal to 2. I is equal to 2 is nothing but 3 and 60. So here we will go ahead and take 3 minus 4, and then here you will go ahead and write 60 minus 70. Okay. Similarly, I will go ahead and write my third number, 4 minus 4, 70 minus 70. Okay, you can go ahead and see to it. Then you have 5 minus 4. It is nothing but your 80 is there. 80 minus 70. And finally, 6 minus 4 multiplied by 90 minus 70. Right? This is all divided by n minus 1. What is n? N is nothing but, so if you go ahead and probably see to it, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And it is n minus 1. So we'll go ahead and calculate this with 4. Okay. So just do the calculation. I think I've done the calculation. It will be somewhere around 20. Okay. And just let me know in the comment section whether the calculation is right or not. But I think this should be the right answer. Okay. Now see, I'm getting a positive value. So here, this positive value indicates the positive covariance. Positive covariance. It indicates the number of hours studied increases the exam score. Increases the exam scores also. Right? So this is true. Right? Over here, definitely. And if I have some other kind of data, you just go ahead and calculate. You may also get negative correlation. That basically means if your x is increasing, y is decreasing. If that kind of relationship is there, then you'll get a negative value. But here we got a positive value. Okay. So let's say if I have also some data like this, let's say I have x and y. Let's say consider that I have 7, 10, then I have 6, then I have 12, 5, 14. Just go ahead and calculate the covariance for this. And this you will be getting a negative value. This indicates that when x is increasing, y is decreasing. And when y is increasing, x is decreasing. This indicates this relationship. If it follows this relationship, you are going to get a negative covariance. Okay. So I hope you got an idea about covariance, right? What exactly is covariance and how do we specifically use covariance? Okay. Now let's talk about some very good advantages and disadvantages of using covariance. Okay. So first of all, let's go ahead with the advantages. Now, first advantage is that you'll be able to quantify the relationship between x and y. This is one of the major advantage between x and y. Okay. Now let's talk about the disadvantage, which is also really important. Okay. And obviously this is good. And I'll tell you the real application of this. What happens if we are able to quantify the relationship between x and y. Okay. So the disadvantage is nothing but over here. I'll go ahead and write. Covariance does not have a specific limit value. Limit value. Now what does this basically mean? Let's say if I go ahead and calculate my covariance, this value may range between minus infinity to plus infinity. There is no specific limitation. Okay. Like it will be ranging between this value itself. So what happens because of this? Let's say I have 3 variables. Okay. 3 random variables. Let's say if I go ahead and find out the relationship between A and B. Let's say if I get plus 20. And let's say if I go ahead and calculate B and C, I may get plus 30. Okay. And let's say that if I go ahead and calculate A and C covariance, let's say I get plus 40. Now here you can see that if I'm trying to find out this particular relationship, okay, I will not be able to tell that the covariance of A comma B will be greater than, let's say over here, covariance of A comma B is 20. Okay. And here let me just remove this. I have calculated the covariance of B comma C. I have 30, right? Now, if I have 30 value over here, if I have 20 value over here, I cannot say in this scenario that covariance of B comma C is greater than A comma B. The reason is very simple, because here we are not restricting. The limit value is not at all restricted. Okay, it can be plus 300 also. It can be plus 300, it can be plus 100, right? We cannot say that which one is stronger. If it is minus 300 and this is also minus 200, we cannot say which one is much more stronger. The reason is very simple, because covariance does not limit that covariance value, how much positive or how much negative. This is the major disadvantage, right? And at the end of the day, we should always try to restrict this covariance value to some limit. If I am able to limit it between minus 1 to plus 1, then it would be great. Why? Because let's say if I say my covariance of A comma B and covariance of B comma C, if this is, let's say, 0.98 and this is 0.96, here I can say, hey, this covariance is more than this. But in this scenario right now, we do not have any limit, and there is no way that we can say, hey, even though this shows 300, I cannot say, hey, this is stronger than this. The covariance is stronger than this in this scenario. This is the major disadvantage of having covariance. So for this, what we do is that we specifically use another type of the statistical analysis techniques, which is basically called as correlation. So the second type which we specifically have is something called as correlation. Now in correlation also, you have two types. One is Pearson correlation coefficient, and the second type is basically called as Spearman rank correlation. Spearman rank correlation. Now let's go ahead and talk about Pearson correlation coefficient. So this is the first topic that we're going to discuss about. It is nothing but Pearson correlation coefficient. Okay. So this is the first topic that we'll talk about. Now, what does Pearson correlation coefficient do is that it limits the values between minus 1 to plus 1. Okay. That is what it is basically doing. Now, before in covariance, I used to get this limit between minus infinity to plus infinity. It can have any value. But what Pearson correlation coefficient is doing is that it is limiting all the values of relationship between x and y between minus 1 to plus 1. So for this, let's go ahead and see the formula. So this is my rho. This is how we write Pearson correlation is equal to covariance of x comma y. So here also we go ahead and calculate covariance, but we divide by standard deviation of x and standard deviation of y. Once we divide this by standard deviation of x and y, this entire value will get limited between minus 1 to plus 1. Okay. And because of this, we can now clearly say that which correlation is very stronger compared to what. Okay. Now understand over here. Here I will go ahead and write some important point. The more the value towards plus 1, the more positive correlated x and y is. Okay. Second point over here, right? The more the value towards minus 1, the more negative correlated it is. Okay. Specifically x and y. Okay. And this is all possible because of Spearman. This is all possible because of the Pearson correlation coefficient. Now you take the same problem, right? Here we got the covariance as 20. Okay. So if you probably go ahead and see this particular formula, covariance, we have calculated it as 20. Now this 20 will be further divided by standard deviation of X and standard deviation of Y. Okay. Now, if I am able to, you can probably do the calculation, guys. Then the finally you will be getting this value will be ranging between -1 to +1. Specifically, this will be more than 0 because I've got a positive correlation over here, but it will be between 0 to 1. Specifically, this particular value will be coming between 0 to 1. Why? Because this is already positive correlated. Okay. Now, this is one amazing important thing about Pearson correlation coefficient. Okay. Now, there is also one more technique which is called as Spearman rank correlation. Okay. So, let's talk about this particular technique. Spearman rank correlation. Okay. Spearman rank correlation. Now for this, what I will do is that I will quickly show you one amazing thing, that is Wikipedia. Okay. And let's go to the Wikipedia and let's talk about Spearman rank correlation. Okay. So here you'll be able to see the first link is Wikipedia only. Now please observe on this figure. Okay. Please observe on this figure. And let's talk about this figure. Now in this figure that you will be seeing, I have this kind of data. Okay. When I have this kind of data, okay, and let me just show some more thing over here. Let me just go ahead and write Pearson correlation coefficient. Okay. And again, I will go to my Wikipedia. Wikipedia is amazing, guys. And let's observe this. So in Pearson correlation coefficient, let's say all the points are in one line, just like this, right? And you can see over here, it follows this particular relationship wherein X increases, Y is decreasing, right? So this Pearson correlation coefficient, you are getting -1. If I go and calculate for this, where my point is scattered here and there, you'll be able to see that my Pearson correlation coefficient for this is between -1 to 0. Okay. Similarly, if you have this, when X is increasing, Y is increasing, X is decreasing, Y is decreasing. In that relationship, your value ranges between 0 to 1, +1. And if all the points are in the straight line, but it is in the increasing order, so when X is increasing, Y is increasing, when X is decreasing, Y is decreasing, you'll be getting like this. And if you have a scattered point somewhere like this, where there is no relation at all, then your correlation, Pearson correlation will be 0. More example you can see over here. Let's say all these data points are in straight line, I'm getting 1. If these data points are in this line, I'm getting 0.8. If it is in like this, then 0.4, then 0, -0.4, -0.8, -1, right? Then with respect to this kind of data point, 1, 1, 1, 1, then you have -1, -1, -1. Why? Because here X and Y are inversely proportional. Here they are directly proportional. And with respect to this, here we don't have any kind of pattern. So all the values which we calculated with the help of Pearson correlation coefficient is probably coming as 0. Okay. Now let's understand when do we use this Spearman rank correlation coefficient. Really important topic altogether. Let's understand about this. Now see, for this particular data points, you can see over here, it follows one kind of relationship. Okay. And let me do one thing. The best way will be that I will just try to take a screenshot of this. Okay. Let's take a screenshot. Okay. I'll copy it over here. I'll paste it over here so that you can also refer it. Okay. And this will be really helpful for you all to understand. Let's say I have this data point. Let's observe this data point. Observing this data point is important. Okay. Okay. Now let's see this. Okay. Over here, if I probably consider every data point, okay, every data point, what kind of relationship it actually follows? So here you can see that when X is increasing, Y is increasing, when X is decreasing, Y is decreasing. Obviously for this scenario, I know that for every data point of X, there is a Y data point and it is in the increasing order, right? So based on this, even this is a scenario in Pearson correlation coefficient. If you go ahead and calculate this, you are getting the value as 0.88. Over here you can see you're getting it as 0.88. Now why you may be getting as 0.88, but you can see for every data point it is increasing. It is following this particular relationship, right? But why still you are getting it as 0.88? You should have got as 1, right? Because X and Y are directly proportional. For every data point when X is increasing, Y is also increasing. For every data point when X is decreasing, Y is decreasing. But over here, if you see this region, there are some data points which is increasing in a slower rate, right? In this particular region. And because of this, your Pearson correlation is coming as 0.88. Now, one problem with Pearson correlation is that if you just have a linear data, let's say if you have data points which looks like this, which are just in one line. For this, if we go ahead and calculate with the help of Pearson correlation, I will be able to get 1. But if I have non-linear data, if I have like this, if I have non-linear data, something like this. See, in this data, I have something like this kind of graph, right? I have this kind of graph. Now, in this scenario, this value will be ranging between 0 to 1. But we know that for every data point, when X is increasing, Y is increasing only, right? So, Pearson correlation will not be able to capture. Pearson correlation is not able to capture the correlation for non-linear data. For non-linear data. What does non-linear data basically mean? Let's see this example. In this scenario, when I have my X and Y, this is my X and Y, right? In this, my data points look something like this. Let's say my data point looks something like this. Now, all the data points are not in straight line, right? With respect to every data points here, you will be able to see that there is a change, right? Here, there may be less decrease of X and Y, but here there may be more, right? So, Pearson correlation is not able to capture this information very much properly. And that is the reason you are able to see that if you try to find out the value, it is coming as 0.88. But exactly it should be 1 only, because at every data point, this is increasing. And this is what Spearman correlation actually does, right? Disadvantage is basically solved by Spearman rank correlation. What is the full form of, what is the formula in actually calculating the Spearman rank correlation? It is nothing but R of S. Here, instead of calculating the covariance of X and Y, we calculate covariance of rank of X and rank of Y. Okay. And this will specifically be divided by standard deviation of rank of X, comma, multiplied by standard deviation of rank of Y. Now, what exactly is this rank? Let's consider that I have my X, Y coordinate. I have 1, 2, 3, 4, 5, 6, 7, 8. And then you have 0, 7, right? So if I go ahead and calculate the rank of X, so here you will go ahead and see, right? 0 is given which rank, right? What 0 value will be given, which rank it will be given, right? Or 7 will be given what rank? So here 7 is the highest number, so rank can be given as 1, right? Or let me do in this way, right? Which is the smallest number over here, 0. So this will be given the rank as 1, right? Less value. Then you have 1. This will be given the rank of 2. This will be given the rank of 3. This will be given the rank of 4. This will be given the rank of 5. Now here we are going to consider the rank, right? And based on that, we are going to sort the numbers, right? Rank of Y is nothing but, which is the smallest number, 2. So here I will give it as 1. Then you have 4. Then you have 3. Then you have 4. Then you have 5, right? So just by giving this specific rank, you know that now your values, when you try to calculate with respect to this, you will be able to capture this nonlinear properties also. And because of this, your Spearman correlation will be always equal to 1. Even though you have less deviation from here, where your X is increasing, Y is also increasing by a lesser amount, at any point of time, it will be able to capture this entire information. Okay. And that is how you are able to get that non-linear properties getting captured. Very simple. With the help of Pearson correlation coefficient, you're not able to capture this non-linear thing. That is the reason you can see in this diagram, when we have this kind of data, whereas X is increasing, with this, it is following this relationship also, but your Pearson correlation is just giving 0.88. The reason is that at this point of time, right, when X is increasing, Y may not be increasing that much when we compare to this particular data points. So because of that, your Pearson correlation does not capture the entire non-linear information. Yes, for linear information, it will be able to capture. It will give you exactly 1. So similarly, what we do is that we use Spearman rank correlation, and here this is the specific formula wherein we just don't directly calculate the covariance with respect to x and y. Instead, we focus on rank of x and rank of y. Rank of x is rank of y is nothing but the numbers, a specific number based on the number itself, a specific rank is given. Let's say the smallest number will be given a smallest rank, the largest number will be given a larger rank, right? And that is how you probably go ahead and do it. Now, still, the main important question comes that, Krish, how do we use this in real world scenario? In data science, when you do EDA or when you do feature engineering, there is a concept called as feature selection. Now, in feature selection, let's say I have some parameters, like I have some features like size of house, right? Number of rooms, okay? And let's say I have price, okay? Let's say that if I increase the size of the house and in the number of rooms increases, then you can know that there is a direct correlation over here. So the price will also increase, right? Let's say that I go ahead and add another parameter, another feature over here, location. So if the location changes to a new city, then also we know that the price will still increase, right? Yeah. So this information, because of this information, this is increasing. So we can definitely say that this is directly correlated, this is directly correlated, this is directly correlated with respect to the output feature, that is price, because we need to predict this specific output, right? Now these three features are very important and it is directly correlated to the price. If this is going to increase, this price will also increase. If this is going to decrease, this price will also decrease, okay? Now let's say that I go ahead and add another feature. Let's say whether the house is haunted or not. If the house is haunted, then what will happen? If the house is haunted, the price is going to decrease, right? So here you can see that there is a negative correlation, right? If the house is haunted, definitely the price is going to decrease because everybody will say in the market, hey, there is some ghost in that particular in that particular house. So it is not better that you buy it, right? So because of that, what will happen? Negative correlation will be there. So the price will decrease. Now let me say that there is one more feature, which is called as number of people staying in the house. Do you think this feature will be directly proportional to the price? The answer is no. Why? Because in one house, any number of people will be probably staying, right? So this and this feature are not at all correlated, right? So if I go and try to find out the correlation between this and this, it will be approximately equal to 0, right? This will be exactly equal to 0. Why? Because this is not an important feature. How can number of people staying in the house become a very important feature? Now what we can do is that with the help of correlation, we can find out what is the correlated value. If the correlated value is approximately equal to 0 or near to 0, I can directly delete this feature. I don't want it because this is not playing a very important role to predict my price. But these all are very important features, right? Because these are all positively correlated. This is negatively correlated. This will actually help me to determine the price of the house in a proper way. And this is what feature selection is all about. In data science, what we do, as a data analyst, what we do is that what are the important features that we really need to consider for our model building or for our use case solving. And right now here, I can definitely see that this particular feature is not that important, right? So yes, I hope you got an idea about it. In this video, I have discussed about all the important things about covariance and correlation. In correlation, we have discussed about two important things. One is Pearson correlation coefficient and Spearman rank correlation coefficient. In covariance, we do not have a specific limit value. With the help of Pearson correlation coefficient, the value is between -1 to +1. Spearman rank correlation will also be able to capture the non-linear properties of X and Y features, whereas in Pearson, we were not able to do that. So I hope you were able to understand this entire video. I hope I was able to explain it in a much more better way. Please go ahead and revise it again so that you'll be able to get a clear understanding. So yes, this was it from my side. I'll see you all in the next video. Thank you.